This is Hacker Public Radio episode 3219 for Thursday the 3rd of December 2020. Today's show is entitled Linux Inlaws S01E18, Voice Recognition and Text-to-Speech and is part of the series Linux Inlaws. It is hosted by Monochrome and is about 77 minutes long and carries an explicit flag. The summary is how to place fake prank calls into podcasts and what does TTS have to do with this.
This episode of HPR is brought to you by archive.org. Support universal access to all knowledge by heading over to archive.org/donate.
This is Linux Inlaws, a podcast on topics around free and open source software, any associated contraband, communism, the revolution in general, and whatever else fancies your tickle. Please note that this and other episodes may contain strong language, offensive humor, and other certainly not politically correct language. You have been warned. Our parents insisted on this disclaimer. Happy, Mum? Thus, the content is not suitable for consumption in the workplace, especially when played back on a speaker in an open plan office or similar environments. Any minors under the age of 35, or any pets, including fluffy little killer bunnies, your trusted guide dog, unless on speed, and cute T-Rexes or other associated dinosaurs.
You may want to do your intro now.
Welcome to Linux Inlaws, Season 1, Episode IT. So fucking hell!
What?
Okay, no, sorry. Let's do it again. Okay, cut. This is Linux Inlaws, Season 1, Episode 18, the one with the text-to-speech and the speech-to-text. Martin, how are things? Do I hear your phone ringing, Martin?
I think that's your phone, actually. Do you want to answer that?
Why don't you pick it up, Martin?
I think it's for you. I think it's got your name on the. I'll pass it through to you. Here you go.
Thank you.
Hallo, willkommen zu Rainbow Escorts. Du sprichst mit Beate.
Hallo Beate, wie geht es dir?
Guten Abend, Chris. Wie geht's? Du bist schon wieder zurück?
Bei den Sonderangeboten konnte ich nicht Nein sagen.
Was kann ich diesmal für dich tun? Hoffentlich nicht so bizarres wie beim letzten Mal.
Du könntest deine AI aufpolieren, weil du nicht meinen Aussagen folgst.
Tough.
You see, Martin, the thing is, the German doesn't cut it, right?
That's not bad.
I mean, I get the overall idea, and that was actually quite good. But you see, now the beauty comes into play when you basically combine this. When you combine this with the proper IE, not something stitched up.
What do you mean by proper?
Well, she wasn't responding to my statements.
Okay. This is the next step. Yeah,
before we go any further, listeners, maybe a little bit of context. This episode is about text-to-speech and voice recognition. Martin's favorite subject of long time.
That's what you think.
Okay, I stated it correctly. Fair enough. Something that Martin has been looking forward to for half a year or something. We pretty much did the episode with the Terminator interview. Long-time listeners will recall, it was, I think, somewhere in March of this year. It's in the show notes. People look it up. So Martin has been nagging me ever since to do a special on text-to-speech and speech recognition. And what you just heard was actually a impersonation by Emma, our beloved Emma. Emma, if you're listening to this...
No, it wasn't. It was Beate.
Sorry, Beate.
Pay attention, man.
No, I wasn't paying attention at the time. Beate, if you're listening, this is not you. This is just an impersonation. This is very important.
I see.
Okay,
right.
Martin.
Anyway, she's still on the line.
Go ahead.
So she's still on the line. You haven't finished for that yet. Right.
Das wird dich jetzt kosten. Ich fürchte, ich muss Ihnen 1.000 Euro in Rechnung stellen.
Do you speak English too? For our long-time listeners who cannot speak German, I'm just checking.
We can consider English. I'm sure we can find some other listeners who are about to call you.
Are we going to provide a transcript, Martin? Because not everybody speaks German.
Yeah, why not?
Perfect. So, listeners, yes, there will be transcripts. I don't know why Martin picked German. I said, maybe Martin, you want to explain this?
Well, I can't help that Beate is German and wants to speak to you. That's
fair enough.
I can't be held responsible for your actions. Right?
What actions?
Well, yes, the Rainbow Escort one.
Okay, if you could entice Beate to speak English, it wouldn't be bad, I reckon, for the rest of the audience.
Okay, we can sort that out at some point.
Okay.
In the meantime, I think is that the phone again? It is the phone again. I think it's for you again. I'll pass it through, shall I?
Okay, here we go again.
Are you not going to say hello? Or?
Hello. Sorry. Where are my manners?
I don't know. I
Caller. Is this caller?
You don't have telephones in Germany, or what? What's going on here?
Welcome to the show, caller 19. You have reached Linux Inlaws, the show, the phone-in show, where anonymous callers can call in and talk about their recent shenanigans.
I don't think this one is anonymous, actually. But anyway, here we go. Here he comes.
Hello, Chris. This is Dennis, the CFO. An invoice crossed my desk yesterday. It is from a company called Rainbow Escorts. Now, look, Chris,
here we go
this
again.
is clearly not related to your Linux Inlaws work. I suggest you post it to Reader Slabs. I hear they have more of a party there. Goodbye.
I thought we wanted to leave current and past employers out of this. Reader Slabs, if you're listening,
if we think Reader Slabs
this
is well known for
made
their
up. This
fun
is
attitude to work.
Right?
No, this is all over LinkedIn.
I'm not claiming expenses for dubious entertainment gigs.
Okay, that was just a suggestion from Dennis, I think, anyway, so feel free not to do that.
Oh, fucking hell. Post-production, this is going to be cut out, right? Very important. Let me get in touch with them.
Oh, damn, it's a busy enough.
Hello, this is Linux Inlaws, the call-in show. Welcome, caller 20. What can I do for you?
Hello, Chris. This is Dennis, the CFO again. I need some clarification on this purchase order from a Mr. D. Trump for election result improvement services. Now, I appreciate you are trying to boost the company funds, but $5 is not going to balance the books. Come back when you can bring me some proper six-figure purchase. Goodbye.
Dennis, you want to... Sorry, don't hang up. Dennis, you want to take this up with the Russians?
The Russians?
Yes.
Well, why don't you elaborate on the Russians?
Well, it's quite straightforward, right? They did the previous, mastering of the elections. Let's call it this way. So they might as well pony up now.
Right. So this is a completely erroneously posted invoice, purchase order. I see. Nothing related to your work. Glad to hear it.
Fair enough. And why does Trump feature all of a sudden on the show? I thought it was an open source show, Martin.
I can't help who's calling in. This is, your extracurricular activities obviously something to do with this.
Okay, but let's bring on the next caller then.
You think there's more call? Oh, hang on a minute. Maybe you're right. Yeah. Oh, there he goes again. Damn.
This is Linux Inlaws. Sorry. You want to pick it up, Martin, or not?
I'll pick it up. Yeah. Hello. Oh, it's for Chris again. Okay, there you go. I'll pass him through. There you go.
This is Linux Inlaws, caller 21. Welcome to the show. What can I do for you? A mute caller. Excellent.
This is Manuel in production. This order for 100 kilos by tomorrow. You think I am a magician? And I hope you have an actual customer for it this time. As the boss I'm gonna be pleased.
Pablo, old friend, I thought you were dead.
This is Manuel, actually. I think he said his name.
So I didn't get that. Sorry, Manuel. You would be Pablo's son, right? Sorry.
Yes.
Sorry, don't worry, Manuel.
So, what 100 kilos
the cash is on the way, don't worry. Again?
What 100 kilos is he referring to here? Are you buying some fish or something?
I don't know.
Okay. Fair enough.
If he's referring to some sort of drug shipment, Manuel, don't sweat it. The cash is on the way, don't worry. If I understand Martin's emails correctly, that is.
Oh, damn.
Martin, you wanna turn off this show for a minute? I don't know.
It's not, yeah. We're not getting around to doing much, are we, with all these phone calls?
No, not really. This is Linux Inlaws, the call-in show for weirdos and other co-hosts. This is caller 22. What can I do for you, caller 22?
Hola, hijo de puta. Manuel tells me you are using my supply for personal use. You carry on that you pay me by 10 tonight or the boys will come and cut off your voice.
Manuel.
This is not Manuel.
No
This is Pablo.
Español. Sorry, I don't speak Spanish, so I can't understand this.
Okay, I thought you'd have some experience with all your dealings with them by the sound of it.
They're not,
maybe I'm mistaken.
The working language of the cartel is actually English, believe it or not. Because funny enough,
you know a lot more than that.
It's the international operation, so don't sweat it.
Right.
Are we done with the phone calls, or?
Well, I don't know. You tell me.
Martin, you can disconnect this gadget. You can, actually.
I can turn the phone. Wait. Oh, no. I think there's another one.
Yes, pick it up, please. Oh, dear. Here we go again.
Hello. Oh, it's for Chris again. Okay, yeah, here he comes. You want to speak to the...
Sorry, yeah, this is Linux Inlaws, the call-in show for weirdos and other people. Your caller 23, please go ahead.
Hi, this is Shannon. You may not remember me, but if I mention Rasheen and Saoirse, I think you will. Ring any bells now? No. School of Nursing and Midwifery make it any clearer. Okay. It was in 1994 and we're both old now, but you need to know this. You have a daughter, and I've run out of money to support her, so send the moolah. Now, I will send you my bank details. Bye-bye and thanks for the fun.
Sharon, just say on the line, I'm terribly sorry, but you do have to get in line. The trouble is, there are about 50 people waiting in front of you. But no matter what, you'll be served in about 20 years' time, so no sweat. But thanks for the call anyway.
What?
I'm not impressed. Any other mystery callers, Mark? Are we on the subject?
I think Shannon's still on the line, actually.
Sorry, Shannon, go ahead. Sorry, I didn't get that.
You are not paying me.
Sorry, I will pay you, but as I said, you have to get in line, I'm afraid. As in, join the queue.
Okay.
I didn't get
I think that's enough. I think that's enough from Shannon.
Shannon, I love you. I've always loved you. You were the special one, but unfortunately, as I said, there are quite a few women in front of you, so no sweat.
Do they all have daughters as well, too? Or they're not turned up?
Well, for some I know, for some I don't, so that's the case. Okay, you want to get to the bottom of this, or should I just take more random callers?
Oh, it's up to you. I can turn the phone off if you like.
That would be a brilliant idea, Martin.
All right, well, let me do that. Otherwise, yeah.
Perfect.
May not get round to the.
Well,
there you go. Done.
Thank you. The call center, of course, can take their details, so they will be gotten back to them at some stage.
Okay.
Not necessarily next week or the month after, but eventually, yes.
Right. I'm sure they'll be very happy with this Well, I mean, I'm not sure about Pablo, though. He mentioned something about 10 tonight, so you may want to deal with him a bit quicker if you
Pablo knows what.
fancy holding on to your bits of anatomy.
Okay, fair enough. Martin, that has been more than impressive. Care to elaborate on how you did it?
Well, I just pick up the phone, right? So.
Oh, dear. That concludes episode 18 of Something Called Study.
So I thought it was 20, but yes, you're right. It's 18, isn't it?
No, 20 would be some Christmas special.
19 is coming up soon, indeed.
Yes. And a big teaser, that would be about Redis, funny enough. But anyway, Martin, okay. Now with this phone gadgetry out of the way, do you want to get onto the main subject of the show?
Yeah, I feel like, yeah.
Which is speech recognition and synthesis.
Well, they're quite different subjects, right? I mean,
yes, they are.
Well, we can touch on the various acronyms first, if you like. There's obviously speech to text, right? You may be familiar with this if you're using, say, Google Chat or something like that has, for example, the option to transcribe what people are saying as you're going along, which is actually pretty decent, I have to say.
This is also known as speech recognition, no?
Pardon?
This is also known as speech recognition.
Yes. Yeah.
Or speech record among friends.
Well, it's speech but yes, recognize it first, change it to text, whatever you need to do with it. But with all the gadgets in your house, I don't know if you have Alexas and all this kind of nonsense. That's obviously the first step if you want to.
Why should I?
Well,
exactly. I mean, for the listeners, for the listeners who are old enough, I mean, speech recognition has been around for at least 40 years.
It's been around long, but it's not in an artificial form.
No,
communication would be a bit tricky.
Computer-based speech recognition, I might add. No, funny enough, basically, I first came in touch with them with technology when I was working at a company called Fidelity Investments about 20 plus years ago. Ooh. When I was project managing CTI technology as in computer telephony integration. And the record technology of choice was then something called Nuance, which was quite advanced at the time, because about more than 20 years ago, actually, that Nuance technology could differentiate between Texan and East Coast accents, which I find quite impressive.
Yeah, I mean, if you, English as a language is obviously quite well defined, but even in the UK, we have a million different little ways of speaking differently.
Of course, the thing is that wasn't English, that was American.
Yes, indeed, American English, there we are. Yeah. So, yes, has been around for a while, but more recently become more, more popularized, I guess, with cars, devices in your home, all these kind of things, right?
Yeah, but I mean, if you're a search engine company that has just gotten lucky, and if you have a few billion of dollars at your disposal, you might as well pour it into fancy AI technology, and speech recognition would be one of them, I suppose.
Yeah. Well, so, I mean, are you referring to Google here? Or?
Yes, I am.
So they just bought a company, right? Back in 2014, they bought DeepMind, which was a UK startup, and that's
keep
what
buying,
all their stuff is based on.
They keep buying companies all the time. I mean,
yeah. So where were we?
We were discussing the origins of speech recognition, which of course goes back to the first projects I think were done in something called the MIT Artificial Intelligence Lab back, I think, in the 60s. Maybe I'm mistaken, but.
No, you're right. I mean, I don't know if I may have mentioned this on a previous show, but my father-in-law, another in-law, was a speech researcher at a UK, let's say, government agency.
I see.
Which we cannot mention, obviously. But yeah, it's been,
What's called it's not Blyby Park. It's Blithey Park or something.
No, that was the second World War one. Have you heard of Cheltenham?
What? I have heard of what?
Of Cheltenham, a town in England. City,
rings
town.
bell. It's next to Milton Keynes, no?
No. but that's okay. It depends how you classify next to it. Anyway,
listeners, please note, Milton Keynes does exist. It does. Yes, if you hear people talking about it doesn't exist, go check it out on the map. Go there. They need the money, especially after Brexit. Just make a point. Visit Milton Keynes. That's the important thing. Milton Keynes Town Council. If you want to get in touch about sponsoring the show,
yes,
by all means.
I thought they had done, considering.
Just send a mail to feedback@linuxinlaws.eu, and we will consider your donation. No sweat.
Alternatively, ring Chris. Yeah.
Oh dear, here we go again.
Anyway, so
ring Martin anyway. Yeah, exactly. Yeah. Sorry.
Cheltenham, town in the UK, has a famous round building in it, which you may be familiar with. No?
Fill me in.
No. Okay. Right. Anyway, this is where the UK listening happens on everything.
Okay.
One a government might be interested in. Well kept secret. Nobody knows where it is, except there's a nice round building. Anyway. Yeah, so anyway, so why does this stuff around, right? Because hiring humans is expensive and they don't work 24 hours a day. So if you can automate this, great.
Okay.
So lots of different research has been done in this field. But I think, well, I don't know what you have found, but I think Google are probably the forerunner in all of this in terms of research and not so much open sourcing everything.
But deep speech is open source, right?
Deep speech is open source, but deep speech is absolute rubbish.
Okay.
In comparison.
In that case, never mind. You will find the link in the show notes. Yes.
Yeah. So if you want to use deep speech to transcribe your recordings, good luck. But there won't be anything usable in there. In fact, what we can do is do a transcription of the show and see.
I'm tempted. Yes. To
do that. And yeah, so advances in hardware. Obviously, these kind of problems are quite suitable to GPUs. So NVIDIA have jumped on this quite heavily as well, making their because there is a large amount of learning required for this. If you want to do it from front to back, that makes sense. You want to do it from. If you just want to not buy a piece of software that does it for you, you want to run your own project. There are some pre-trained models out there, but you will not get the same results as as a Google, right? That's the main answer. So the Googles have the resources, they have the hardware to do millions and millions of hours of training to get it to the stage that they can do that kind of level, which is reasonably impressive, but still.
I mean, correct me if I'm wrong, but I think deep speech is based on something called TensorFlow.
Okay, so
how does it work?
Deep speech. Well, deep speech is not actually text to speech, right? Deep speech is the other way around. And
it's speech synthesis, essentially.
No, deep speech is the project that takes an audio file and transcribes it.
So it's speech recognition. Okay.
Yeah. Sorry, we were talking about various acronyms, weren't we? So we were talking about. So one thing is obviously one way around, right? You want to be able to turn speech into text, which is handy for your search engines, your algorithms. They are a bit tricky to run on sound bites. So if you transcribe into text, you can have tags, and you can obviously search things easier, and so on and so on. So one of the reasons to go and also, I mean, you work in sales, don't you, at a certain company?
I think I do, yeah.
And a lot of these organizations are starting to record conversations with customers and transcribing them.
Okay.
To, feed into their sales forces and whatever they use to, which obviously kind of, begs the question of legality of these kind of practices, but it is a practice that seems to be quite prevalent in your modern sales company. Were you not familiar with that? Okay.
Well, I heard about the concept, yes. But that's it. I don't know. I suppose.
Okay. Yeah, fair enough. Yeah,
speech recognition. I mean, speech recognition, of course, does have its merits if you're talking about bots and stuff, because there are two principal ways you can interact with a bot. You can type in stuff in a window, or you can actually speak to it.
Well, it's bots. It's your things around the house that you want to turn your light on, or stuff like that. If you don't want to get up and press a button, but also in cars, right, where people are actually driving, they should keep their hands on the wheel unless their car is driving for them. But
exactly.
It's a whole different question altogether. So there are some advantages of
I mean, given the fact that deep speech is actually, if that's correct, but let's assume for the moment it is, based on TensorFlow, it would be just another example of something called a domain-specific framework, like carrots for image recognition, deep speech for speech recognition. So, for the listeners who don't know what TensorFlow is, it's essentially a backpropagation network infrastructure where you can train your backpropagation network in order to recognize patterns, because this is basically, at the end of the day, what these domain-specific frameworks boil down to. You essentially recognize patterns, whether it's something in a picture that might be a human, that might be a laptop, that might be a smartphone, or whether it's a waveform, or whether it's a I'm missing the theory here. Whether it's a diphthong, is that what I'm looking for? It's essentially a component of a sound, or a sound rather, that makes up language. And again, that would be a pattern in waveform that a backpropagation network simply picks up.
Yeah.
If I'm not completely mistaken.
Yeah. So I'm okay. So if you mention TensorFlow, you have to mention PyTorch as well, right? So those are the two. TensorFlow obviously originating from Google, PyTorch being the other library that is used for these kind of purposes. So the whole there's different ways to doing. Sorry, I don't know if you're finished, but if we're going on to text to speech, for example, there are different ways of doing it. If you think about, say, have you ever used an Apple phone?
Do I have a what?
An Apple telephone. Oh, no, you don't have telephones in Germany. Sorry, I forgot. Yes.
No, we just use mobile.
Handy. It's handy, isn't it?
Yes. We did away with the fixed lines.
Just the handy, yeah. Who came up with that name?
I do, probably some Dutch guy. I can't remember.
We don't call them handies in Holland. No, we don't. No. It's this pure German thing, you can't blame us for that. Anyway, so German inventor of the German name for mobile phone. Please let us know who you are.
Here we go again.
Maybe he will ring into the show.
Oh no, here we go again.
Anyway, where were we? So,
unplugged the phone.
Pardon? Yes, I have unplugged the phone. I would have to plug it back in.
Don't, man, don't.
Fair enough. In the interest of finishing the episode, I shall not plug it back. Maybe I'll just redirect it to your number. That's probably a much better idea than having me.
Just don't.
Doing...
And
this calls for some automation. Anyway,
and there won't be an extended version of the show with all the sound bites that we cut out, because that's the way it is. Post-production or not.
Yeah. Okay, so if we're talking about the text-to-speech part, then there's two ways of people have approached this. Well, probably more than two, but the two most used ones, it seems, are so my reference to Apple telephones was Siri, obviously, right? So Siri uses a way to generate sound by sticking individual syllables together. So it has sounds for pieces of words, right? So whichever language, if you can cut it into small little pieces of sound bites, and then Siri just kind of sticks these together, right? So that's one way of doing it, which is completely different to WaveNet, which is really what powers Google's TTS on the synthesis side. So where the actual audio is being produced. So you have, which is using neural networks instead to create the speech, and it's really creating something called a Mel spectrogram, which is really your representation of your audio in a neuron. Let's call it that. But so it's a more a more crude approach compared to, crude. It's using the power of machine learning, right, rather than just saying doing a rule-based type approach where I'll have little bits of words and I'll stick them together and I'll make sentences and so on. So Google most advanced in this, it seems. The likes of, as I mentioned, NVIDIA, they have a lot of, they're trying to sell their GPUs, right? And they're trying to sell their GPUs not just to people playing games, but also because there's only so many desktop computers or even laptops with NVIDIA GPUs they can sell. Whereas in the enterprise, if you can apply or sell GPUs there, then you can stick multiple in the machine, and then you can make them bigger and faster, and people can buy even more of them. They even have a whole portable data center where you can plug bunches of these GPU machines together and create yourself a great big GPU lab, which is what they were intending to do. Or what they're claiming they're going to be doing after the ARM purchase goes through to set up one of these ones in Cambridge. But
as not everybody listening is probably an expert on TensorFlow and related technologies, maybe we should explain a little bit why GPUs come in handy if you want to take a look at backpropagation networks in general and TensorFlow in particular. Essentially, the way it works, TensorFlow, and the clue is actually in the name, models a backpropagation network, which essentially is a layered net of neurons that have certain characteristics and that are able to recognize patterns, because this is what TensorFlow and PyTorch are all about. Essentially, what TensorFlow and friends do, they boil down this recognition to simple linear algebra operations. Given the fact that a tensor is, in layman's terms, something very similar to a matrix or a vector, these operations can be very efficiently executed on a GPU. Because if you take a close look of how shaders, which are one of the central components of a GPU, work, all they do is essentially linear algebra operations, but very fast, because these shaders have been designed with that purpose in mind. This is the reason why you see companies like NVIDIA, AMD, and all the rest of them moving away from simple graphics to actually GPU as in general purpose GPUs that are able to power these artificial intelligence infrastructures left, right, and center. You actually can see this in the offerings of the hyperscalers. You have TPUs at Google who do little else than just processing tensors, because this is what they're known for, tensor processing units, TPUs. Yep. And Microsoft, I think, has something similar. And I reckon AWS, I think, has two. And I reckon it's only a matter of time.
AWS use standard GPUs, by the way. But,
okay. And yeah, I think, yeah, okay. And it's only a matter of time if Alibaba doesn't have it yet before Alibaba catches on.
Yeah, so the whole hardware field is quite interesting. As you say, you have your general GPUs. Google have done their TPUs. There's a small startup in UK called GraphCore, which links in the show notes, which have built their own what they call IPU, which is specifically designed for AI purposes as well. So, I mean, the biggest difference between, we're all used to CPU processing and stuff like that. Biggest difference is really that the basis of what both of the, at a very high level, these two technologies are built for, which is CPU is built for latency, and GPUs are built for throughput. If you can parallelize your problem, you have a benefit of running it on a GPU in short terms. Whereas CPUs are all about context switching and getting a fast response for whatever request needs to happen. But yeah, it's I mean, sort of digressing slightly into the hardware field, but even things like FPGAs are, people are not just, what I've come across over the last few years is people are the whole surge of, we need to have standard 386 boxes for everything and just build the software around it. There are very specific benefits to be gained by using hardware, FPGAs, low latency, financial trading. Even our friends at Amazon are building are implementing FPGAs again for their Redshift database, which
we should probably mention what FGPAs are, Martin.
Field programmable gate arrays. Yeah.
Not everybody knows this.
No. Okay. Sorry. That's links in the show notes.
Sorry, a field programmable gate array.
Programmable hardware. Yeah.
Yes, it's essentially a piece of silicon that can be easily modified based on your specific requirements. Think of it like a poor man's CPU, but in contrast to Intel, AMD, and all the rest of them, you can actually modify the execution. The instruction set that they're executing.
Yep.
Then you have it. So what normally CPUs do is essentially, and Intel is probably the best example. Intel has moved away from the traditional CISC model to something called RISC, but you don't see this because Pentium, it's all hidden under what's what I'm looking for? Not microcode, but microcode, right?
Yeah.
So when you power up a CPU, essentially, it executes at the very core like a RISC architecture, but it looks like from the outside like a CISC architecture. So the die understands RISC instructions, and the rest is software. So when you buy a Core i5, i7, i3 these days, or an i9, you essentially buy a very sophisticated piece of RISC architecture well hidden under a CISC shell. That's what it works.
Mm-hmm. Yeah.
So the thing is, FGPAs take away this layer and give you the full power of being able to program these somewhat simpler CPUs. I wouldn't even call them CPUs. They're gate arrays, right? Like every CPU is, but only in a much more customizable way.
Yeah,
exactly. This is the way it is. And FGPAs are not something new. They have been around at least for the last 30, 40 years.
But
Only,
just,
only these days much more, what's what I'm looking for? Not compressed, but more integrated. Yes.
Yeah, it's just surprising that with the whole story that was always just scale up by adding more hardware, but there are benefits to be gained by using specific hardware for certain problems, right?
That's really of course, the beauty is with using specialized hardware, as Martin just mentioned. CPUs were designed for a particular purpose, to execute software very efficiently. But due to that, they have to cater for a wide variety of use cases. You actually see this in CISC. CISC has a very, and hence the name, complex instruction set architecture. Complex instruction set. What's a C?
Computing?
You find the show notes.
I think so. It's got to be, isn't it?
If you take a look, and that goes back to the old mainframe days. 370 and slash system/36 had quite a large instruction set. And I think it's back in a previous episode. I think I elaborated on that before. About in the 70s, somebody took a very close look at how many instructions in a COBOL compiler of sorts are actually executed from this complex instruction set that was provided by IBM mainframes. And he came up with a percentage of about 15 to 20. So hence RISC was born, and the first project that IBM did was actually called ROM, where they took a mainframe instruction set and slimmed it down to a very narrow instruction set. And ARM of Acorn fame just took that concept further, reduced it even further, along with Rockwell 6502 comes to mind, all the rest of them. And at the end of the day, something called ARM, Advanced RISC Machines, was born. And the rest is history with regards to Android, Apple. Speaking of M1, that has just been launched. We're recording this episode on the 13th of November, so M1, exactly, M1 has just hit the streets. So this is essentially the idea behind RISC. So you take a very reduced instruction set, put it into silicon, but in contrast to CISC, because there are not that many instructions to execute, you can do it very, very much faster. The idea is that you do the rest. In terms of the remaining complexity, you shift this off to software. You see this actually in the code generators of compilers like CLang or GCC. Where a lot of effort has flown into the optimization stages when you actually specify a RISC processor as the compilation target. The same goes for much more specialized hardware, like TPUs, like GPUs, like other specialized hardware that is only able to execute a very narrow scope of instructions, but does it so very efficiently. Hence this whole craze about GPUs, TPUs, and all the rest of them.
Well, there's also the whole underlying build of the processor, right? That if you look at the images of them, you can see why they are they're built for these purposes. And
absolutely.
Yeah.
But we digress, I think.
Maybe. That's fine. We can always turn the telephone back on. Yeah.
No, we can't, Martin. Okay, back to text-to-speech.
Yeah,
I think you were discussing WaveNet and Friends.
Yeah, so WaveNet is the final part, right? To produce the waveform after the whole after the spectrograms have been generated before that. So I mean, there's a load of good papers around this subject.
Martin, before we go further, what's a spectrogram?
The spectrum is really an image of your. Well, it's not an image. You can represent it as an image, but it's a representation of audio. Think of it as your over time, so you can think about, okay, so if you look at your Audacity, whatever it is, whatever audio program you do, there is you can see the amplitude of your voice. Basically, that's all you can see, right? You can't see any other attributes that associate with that. You can just see the volume level pretty much, right? If you want to add other dimensions to that, then that is really what a mel spectrogram is. So you're adding more dimensions to a waveform than just. Spectrograms have obviously been around for other purposes, right? This is where the name spectrum analyzer comes from and things like that.
But maybe now is the time to explain actually how you take a piece of text and you derive at something called synthesized speech. You want to take this, Martin, or should I elaborate on this?
Why don't you have a go?
No problem. If you take a look at normal text is composed of syllables. These syllables have a certain pronunciation. I'm not a linguist, disclaimer, very important. Essentially, the way it works is you take these syllables and turn them into something called phonemes. And these phonemes are the basic building blocks for something called words. And if you string words together, you have ultimately a sentence. The thing is, of course, if you just take a phoneme in terms of if you take a piece of text and if you try to generate a waveform based on a particular phoneme, it may sound very metallic, very, very, very artificial. This is what you see with traditional TTS approaches. And then you have, and this is where the magic comes in. And then you have essentially artificial intelligence who, similar to other domain-specific frameworks, provide this essential feedback loop, i.e. what you do, you train a backpropagation network by having a TTS generate waveforms, essentially sentences in audio, and then you tell the network what the delta is between a human pronunciation of a sentence, i.e. how a human would utter this in English and German and French and Spanish, whatever, and what the TTS initially generated. If you do this often enough, and this is what WaveNet and these approaches are all about, at the end of the day, you do arrive at a very natural sounding text-to-speech synthesis. And this is what the magic is essentially all about. You tell the backpropagation network, you tell the neural network essentially how humans would pronounce that sort of thing.
Okay, yeah, that's it's a good summary. You need to break down the text, but then the intricacies of a human speech are more than just converting words and letters into sounds. There are other attributes, right, which are volumes, speed, intonation, these kind of things, and that's really what a mel spectrogram is having many more features associated with the input to a sound generator to create different voices, to create different waveforms out of that, essentially. So it's in short, you want to get to a stage where you can have input to your output generator, your waveform generator, which has many features calculated by your network to give you, different voices, different speeds, different pronunciation, etc., etc. Like you heard from our callers, in fact.
Indeed. Care to elaborate, Martin, on how these callers got into existence?
Well, you'd have to ask their parents, I think. In fact, maybe you should ask your parents.
Okay, guys, what you heard, of course, were not real callers.
There's a mummy bee and a daddy bee.
Martin, in about 20 seconds, will elaborate on how he did it.
Really?
The floor is yours, Martin, yes.
Okay.
Spill the beans.
There are a number of different ways to do this. As I mentioned, you can buy commercial software to do this stuff. In fact, if you have a bit of a poke around, you'll find a number of companies that are actually based on open source projects that have implemented these kind of techniques. The main one that's behind a lot of this is Tacotron. Tacotron 2, in fact, it moved on. They moved it forwards a couple of years ago with Tacotron 2, and this is really the most advanced project out there. Now, the biggest issue with all this is really calculating the model, right? There are some pre-trained models out there, not many. But if you want to go and do your own training, you obviously need a data set. You need a lot of sound bites to do that. And the more training you put into this, the better your results are going to be, strangely enough. So I did embark on training Tacotron 2 myself, and soon found out that was going to take a number of weeks on my GPU based laptop. So
you use a pre-trained model.
Yeah, pre-trained models are available. They're not as, Google is not going to release their pre-trained models, but there are pre-trained models out there that people have run several weeks of stuff on. So you can use some of those to give you something. I'll post you the link in the show notes. There are some really impressive results of what Google has done as outputs, right? So you may be familiar with Google's text to speech, right? It has an API. It's obviously based on all the same background code, but just the model is better. They also have an option which is in beta, to have custom voices. So this is kind of the next evolution of this, is really being able to learn adopt a new voice to this. So rather than feeding it sound bites, not many of them, and then it produces results based on those. And some people have. So there are some projects out there. Again, links in show notes. Google is trialing it as a beta in their text-to-speech, but there's also companies like Resemble.ai who have, again, taken an open source project and trying to monetize this. There is Firebird, what's it called?
Lyrebird.
Again, which was a open source project, commercialized. So yeah, there are options, right? If you want to do it yourself, quite a bit of work, and finding the right models, finding the right.
Just sticking to Lyrebird for the moment, but you'll find actually in your standard Ubuntu/w repo, simply install it. I haven't looked at the implementation, but I thought it was actually just a waveform modulator. Does it actually do a full speech recognition and then in turn a full TTS? I thought it was just
no,
waveform.
Correct. It's okay. So sorry, correct. What the Lyrebird that you're talking about is really the one that you can deploy on Ubuntu, download it, whatever it is, untar it, install it, etc. Or just you can even you install it from the repo as well.
Yes, you can. At least on 2010.
Right. So that's a voice changer, right?
That's exactly it. Yes.
Yeah. However, if you look up Lyrebird itself, you'll find out that a company like called Descript has taken on this as a commercial model, which does voice cloning, for example. And there's other ones out there. There's also projects out there that you can use to do that, which I haven't included in this episode, but I'm sure Chris will be volunteering for this one next time. Basically, you take someone's voice and then apply text to speech using that voice, which is always quite fun. Similar to your deepfake AIs where you can project your someone's face on your videos.
Okay.
But maybe that's a topic for another episode.
Indeed.
Actually, it's a bit difficult doing a podcast about deepfakes because we don't have any video.
Yeah, we won't do videos. No, we won't.
No. Yeah. Okay, let's scrap that idea. Yep. All right. Cool. So,
what's left, Martin, to discuss on this? Because I think it's a very interesting topic, and I suppose we could spend hours on end on this.
Well, I think what is left is really where is this going, right? With all things AI, what are the applications, and where do we see the future of these things, right? Apart from
strange fake phone calls coming into podcasts, yes.
Are we going to have fake phone calls? Oh,
we already did, Martin. In case you didn't notice, yes.
Oh, when did that happen?
About an hour ago.
I see.
But don't worry about it.
Well, you obviously pre-warned, otherwise you wouldn't have known.
Whatever.
Where were we? Yeah, so application of this stuff. What do you think?
Well, I mean, this whole smartphone, self-driving car shenanigan comes to mind. I mean, Siri is little else than the cloud-based form of this, right? I mean, you speak to it, it recognizes your sentences, it does the magic in the background, then and then it gets back to you. Same goes for Alexa. Same goes for what's the Google thing called? Google.
Good question. Home, maybe?
Google something.
A big bell. I don't know.
Yeah. And I reckon in about 10 or 15 years, I think Tesla has already something.
Don't forget Cortana as well for Microsoft lovers out there.
Yes, for the 10 listeners.
How many listeners?
Microsoft. Sorry, yes, of course there's Cortana too. Okay, leaving desktops aside, I reckon in about 10 to 15 years time, when you just simply enter your self-driving car, you may actually have this on board, not just running in the cloud, but rather have the onboard processing power to do this locally. It's just a matter of time, and the prices for the likes of TPUs, GPUs coming down to enable mass production. That would be my my guess.
Your Tesla already has GPUs in it, right? So
that's exactly it. I mean, this is what this is headed at the end of the day, and we're just seeing the beginning.
Mm-hmm.
I mean, your own smartphone these days has a 64-bit architecture and at least 8 cores. That's a lot of bang for the buck.
Well, I don't actually use these cores. That's a different question, but there we go. Yep.
Sorry, Martin. These are just CPU cores. GPU is totally different matter. Never mind the surrounding SoC.
Mm-hmm.
And if the M1 that has just launched by Apple is anything to go by, stay tuned. I mean, the M1 has.
You're gonna buy one.
Well, the thing has just been launched.
Apple, if you're listening, why don't you send us one? Yeah.
Maybe 2, actually. Okay.
You want one as well, fair enough.
Yeah. I mean, I haven't looked at the specs, but if current law is anything to go by, you're looking at an 8-core ARM-based design with 16 threads, and this is just the CPU. GPU, I think, has about 4 threads, if I'm not completely mistaken. I might be corrected, maybe 8. Plus, and this is the interesting part, apparently they put image recognition into a special part of the SoC. And, Martin, brace yourself, you can get secure enclaves. Enclaves.
Oh, where did I hear that before?
Well, there was this Anuna company that partnered with a company called Redis Labs about half a year ago. But you see, where Intel is still in the research phase, I think, Apple has done it in hardware and ready to go now. For those listeners, secure enclaves, consider it like a MMU on steroids. Sorry, secure enclaves. Okay, a MMU is essentially protecting pages of memory. That's what a memory management unit is all about. So you make sure that a process from an operating system perspective cannot access the memory of another process. That has been around the block for at least 30 years. I mean, this is standard Unix textbook stuff, right? Same goes for mainframes and all the rest of them. So, but with the advent of viruses, rootkits, and all the rest of them, that simply won't cut the mustard anymore. So what secure enclaves are actually providing is a layer kind of underneath this, where you can only access a certain piece of memory if you have the right credentials, so to speak, in layman's terms. The technical implementation is slightly more complicated. We won't go into the details, but you will find links in the show notes. But think of it like a very secure MMU that only allows you to access a certain piece of memory if you actually can prove that you are who you pretend to be, which is pretty amazing when you think about it, because that will allow you to do something called hypersecure computing.
Yeah.
Where viruses and the ilk would have a very hard time to penetrate other processes' address spaces.
Yeah, I'm just looking at the one.
And you can buy this now from Apple. Apple, as Martin said, if you're listening,
okay,
if you send us 2 machines,
yes,
we will review them, and this is a promise.
I'm not very impressed with the GPU, I have to say. It's only got 2.6 teraflops of throughput. I mean,
which is not an awful lot, yes.
No, I mean, my old RTX does 7.5, so it's like, which entry are we in, Apple? Come on, you can do better.
Martin,
come back when you have the M2 to us.
Martin, have you looked at
you don't need the M1
at the form factor of this machine?
I thought we were talking about chip.
No, I'm talking about the form factor of something called a MacBook Pro 13-inch.
Well, it'll be 13-inch now.
I'm
missing something.
The graphic card that you're referring to probably has the same volume as that whole laptop.
No, it's in my laptop. So.
Yes, it's in your laptop. Okay.
I have an RTX 2070 in my laptop.
It's that laptop that you keep lugging around in your suitcase.
Well, not at the moment. No, I'm not traveling very much.
Okay.
Yeah.
Okay.
Well, it has the added benefit that going to the gym is also not required. So who needs a lightweight Apple? It's just you're just wasting time. You have to then go to the gym as well. It's like, why are you doing, man?
Okay. You have heard it here first.
Here first, yes.
Lightweightness
is not good for you.
Okay. Is there anything else we should mention about TTS or
I think the rest will be in the snow. In the snow notes.
In the snow notes, yes. Along with your 5 grams of coke. Manuel, if you're listening, just send the shipment. Yes.
Yes. Don't forget that 10 o'clock deadline by Pablo. Yeah. We might be ringing in again. Yeah.
Yes, from the grave or something.
Okay.
Very two important messages.
Announcements.
Yes, announcements. Yes. Feedback is always welcome. Of course, feedback at linuxinlaws.eu.
By telephone or email.
We would prefer email, actually. Come to think of it, because feedback at linuxinlaws.eu is not a valid phone number, in case you're wondering. And of course, then there's always a next episode, and this next episode will be about Martin.
That is something.
Indeed.
Yes.
Our favorite NoSQL in-memory database. So stay tuned for another episode of Linux Inlaws.
Excellent. Are they going to explain how it's a database?
Stay tuned.
Okay.
Yeah,
I'm confused.
Sorry,
non-phone feedback. Right.
So hang up the phone, please, Martin. Very important.
Okay, we have written in
hang
feedback.
Up the phone.
Cool.
Yes. Yes. The League about Affirmative Action on POCs wrote in and complained that we haven't done poxes and anti-poxers for quite some time. And of course, they're spot on.
Yeah.
So Martin, now
so is this league, is that something similar to the Society for putting things on top of other things?
Something like that, yeah. So Martin, what's your pox of the week?
My pox of the week. Well, it's not the Apple M1 because I'm very unimpressed with the GPU performance. Pox of the week.
I guess that would be the Martin's anti-pox, I suppose.
So,
what's your pox?
The single and only pox of the week. Let me think for a second. There are quite a few.
Confine yourself to one in the interest of time.
Yeah, so this is, I need to pick one, right? Well, yeah, there's so many. Which one? Okay, let's have a think about our listeners. What would they find most relevant? Okay, most relevant. Right, here we go. Pox of the week for relevancy is a company called Shell, who has started an open source collaboration platform for
the petrol company.
Indeed, data science on geophysics. Indeed, called the OSDU, if I'm not correct, mistaken.
Links, I hope, would win the show notes.
Yes, I can remember this one. Yeah. So yeah, that kind of surprised me. A company like Shell who's all about making billions of money, but they're actually trying to bring back in the community. So nice one. Shell.
Cool. Okay. Anti-pox we already discussed. My pox would be a book called On the Road by Karuk.
Hang on. Whoa, hang on a minute.
Why?
What is this? This is not open source related.
Correct. But then the poxes don't have to be open source related.
Yeah, did you?
No, they don't.
Do?
No.
Well,
you didn't with the statues. Okay.
Sorry, I forgot you just have a hobby called Better Slabs, don't you? Yes.
Sorry, poxes, Martin, per definition, can be anything. Movies,
yes,
books,
yes.
whatever.
This is my point. That having Better Slabs as a hobby leaves you with a lot of spare time to read books. Right. Got it.
Okay, my pox of the week, without going into this insult, is a book called On the Road by Karuk. I think is his name.
I don't know.
I'm not too sure about his first name. Let me double check.
Well prepared box.
Absolutely, Jack Kerouac. You find the links in the show notes.
I've heard of him.
Yes, it's
What else did he write? He wrote something else.
No.
He's ages old, isn't he? Wait.
Absolutely. That book was published in the 50s or 60s.
Did he not write a book about wolves and stuff?
No.
I know the guy.
Steppenwolf was done by... Steppenwolf was done by... I can't remember the German author.
Isn't that a band?
No, it's actually a book.
Okay. No, I'm just gonna look up the book that I was thinking of. Because I actually read something of his, which was pretty good.
Steppenwolf was done by Hesse, actually, so that's not what I'm referring to. Jack Kerouac wrote On the Road. Essentially, it's a road movie in a book. You have these posse of characters that keep crisscrossing the states in the late 40s. There's a lot of drugs. There's a lot of shenanigans going on. I found this very inspirational. Just read it. My anti-pox would be a guy called...
Wait. What inspirational? Why?
Because it just pictures the vibes of the time, I suppose.
Okay.
Because Second World War was just over, and these people just are experiencing things. Let's put it this way.
Okay.
A lot of boozing involved, a lot of womanizing involved. Just read the book.
It's
a classic, so to speak.
Now it's all clear.
Yes.
Okay, come on. Your anti-pox, yes.
My anti-pox would be a guy called Joe Biden. Not sure if that rings a bell. He's supposed to be the 7th president, if I'm completely mistaken. Successor of a guy called Donald J. Trump.
Yes.
Mark, we have to get this guy on the show, right? Isn't Donald Trump?
We do?
Why not?
Well, I don't know. I don't think his $5 contribution to the manipulation of election results services by yourself is really a reason to put him on the show.
Maybe he can talk about the open source angle here. I don't know. Anyway, why is this an envypox? Of course. I mean, we're talking, as I said, we're recording this on the 13th of November. And now I think Joe Biden is clocking in at 290 votes in the electoral college. Of course, that takes out all of the suspension about the further process, because by now it's very clear that never mind what the liar in the White House tweets tonight.
So why is Joe Biden an anti-pox?
Because, as I said, he just takes out of the suspension. He just takes out of the whole thing, because by now he's clearly won. And never mind what a certain guy called Donald J. Trump thinks.
Oh, you were looking for a bit of a fight. Right, I got it.
No, I'm not.
Oh, okay.
No, just from now, it's just boring, right? I mean, it's clear who's won.
It's boring before that anyway, in my opinion. That's politics for you.
Donald, if you're listening, just call back lawyers, because you won't get anywhere. Full stop. Better spend this money on drugs, hotel renovation, and some other stuff.
Yeah, and how many US presidents were assassinated again?
4?
Is it 4?
I don't know.
A few. I think it's quite a few.
Kennedy. Who else?
Oh, loads.
No, it can't be loads.
Yeah, they're always knocking them off left, right, center.
You find the details in show notes. What you won't find is a how.
It was 4, right? I mean, surely you remember Lincoln as well.
That makes it 2.
I don't know who the other 2 were, but I'm sure the number 4 rings a bell. And then there've been some. Oh no, Reagan, he didn't die, did he? I think someone.
No, he didn't.
Tried to. He got lucky. But yeah, you can imagine that Biden is next, right? So
why?
What do you mean why? You know what Trump supporters are like.
I bet you a crate of beer, and I'm not talking about this lukewarm piss called beer in the UK.
Like the other crate of beer you haven't produced yet. For my excellent insights.
Martin, I won this bet, if you recall.
Well, that's to be seen.
No, I did.
Who is running the Venice Labs, the Venice project right now?
It
is it
doesn't matter.
Yeah.
No, it doesn't matter, Martin. I won.
Only in pure theoretical, but I won morally. Anyway.
To quote a certain Martin,
Salvatore, if you're listening, when you're coming on the show, man.
To quote a certain Martin Visser, technically you've won this bet. So you might as well scrap the term technically, because I've won this bet. So full stop.
No, technically it has to stay in there. That's right.
So you owe me a crate of beer, and I'm more than happy to wager you a second crate of beer.
Nice
that Biden doing his first term, and I'm just talking about the first term, will not be assassinated.
What about if he just sort of falls over and dies?
That's a different story. Sorry,
can we include that one?
No. By assassinated, I mean, of course, not dying of a natural cause.
Well,
I know it's somewhat of a blurred line. Fair enough.
Yes, it is.
But if somebody shoots Biden, that's not a natural cause, right?
What if the Russians poison him?
You see, this is what I mean by a blurred line.
Exactly.
If I can prove that the Russians have actually poisoned Biden, that would be an assassination. So
Indeed.
You would owe me a crate of beer.
Yes.
Now, Martin,
you would owe me a crate of beer, actually.
No, I just said that Biden won't be assassinated.
Yes, indeed.
No, Martin, if you manage to cover this up, I owe you a crate of beer. Fair enough.
What are you talking about? If Biden is assassinated, you owe me beer. Right,
if Biden dies, and if you're behind this, and if you manage to
I'm behind it,
yes.
No.
To make it look like natural death, you get that beer. No worries. Makes sense.
Okay. I'm not entirely sure what the bet is now, but yeah. If you're listening, Joe, we hope you live long and prosper. There we go.
Yes, we do. And Joe, let's have that crate of beer between the three of us. You're invited.
Yes.
Yes. Okay.
Yes.
So these would be my poxes and epoxes. Sorry, this will be my anti-pox. We've discussed Martin's poxes and anti-pox, and that actually now finally concludes the show.
Okay.
See you around next time.
Yep.
This is the Linux Inlaws.
You come for the knowledge,
but stay for the madness.
Thank you for listening.
This podcast is licensed under the latest version of the Creative Commons license, type Attribution Share Alike. Credits for the intro music go to Blue Sea Roosters for their song Solid Market, to Twin Flames for their piece called The Flow, used for the segment intros, and finally to Celestial Ground for their song Sweet Justice, used by the Dark Side. You find these and other ditties licensed under CC at Jamendo, a website dedicated to liberate the music industry from choking copyright legislation and other crap concepts.
You have to send me the email addresses of IT and post-production so I can write back to them.
Why don't you contact HR?
They might even call in as well.
Okay. Just reach out to HR, just in case.
Oh, yes, of course, yes. Who have we got in HR anyway?
It's HR at linuxinlaws.eu.
Well, this is a bot, is it? We don't have an Alessandra or something.
I don't know. I mean, you hired them. You should know.
I just hired Dennis to look after your expenses.
Oh dear. Okay.
Huh?
Oh, hang on. We haven't done.
Done?
Resume the recording.
Oh, damn, there's another one.
The outtakes. Pick it up, Martin.
Sorry, we haven't. What were you saying? We haven't done what? What have we not done?
The outtakes. I mean, just pick up the phone.
Okay, hang on. Hello, Linux Inlaws here. You're after Chris again. Okay, here he comes.
This is Linux Inlaws. Chris speaking. Yes. How can I help you?
I don't know. You tell me.
I thought you were putting the caller through.
Yes, but I thought you wanted. There was a thing that you wanted to do.
Yeah, but without the phone.
Without the phone. Okay, sorry. I thought you said
sorry.
You've been listening to Hacker Public Radio at hackerpublicradio.org. We are a community podcast network that releases shows every weekday, Monday through Friday. Today's show, like all our shows, was contributed by an HPR listener like yourself. If you ever thought of recording a podcast, then click on our contribute link to find out how easy it really is. Hacker Public Radio was founded by the Digital Dog Pound and the Infonomicon Computer Club and is part of the binary revolution at binrev.com. If you have comments on today's show, please email the host directly, leave a comment on the website, or record a follow-up episode yourself. Unless otherwise stated, today's show is released under a Creative Commons Attribution Share Alike 3.0 license.